So the assignment related to projectile, we have discussed the first 12 questions from this. That was the last question we discussed. In question 13, which is a multiple choice question, as you can see, the object is there, which is launched horizontally. So the ball rolls and take about 0.9 seconds to reach the ground with a launching speed of 1.2 meter per second. So speed at which it is launched, that is 1.2 meter per second. So it's only the horizontal speed. What about the vertical speed? The vertically, if it is launched from certain height, as you can see, there is no component of the vertical motion. So the vertical motion is zero. So all is horizontal. There is no vertical in the beginning. So vertical is zero. Which of the following expression could be used to determine this range? S is a range. So whenever we want to find the horizontal distance, we always use the horizontal component, like whenever we want to find range. So we have the formula speed is distance over time, and this formula is valid if an object is moving at a constant speed. If it was accelerate or decelerate, then we have to use equation of the motion. So speed at which it is launched, that is equals to 1.2. The distance we don't know, and the time it took, that is 0.9. So 0.9 is divided, other side will be multiplied. It will be 1.2 into 0.9. That will give us the horizontal distance, or we can say range. If this was the same question and they asked the height, about the height. If the same, so if I want the distance here, the horizontal distance, which is equals to speed multiplied by time. So speed was equals to 1.2 and time is 0.9. But if I need the vertical height, so we have to use equation of the motion in which S is equals to the equation of the motion. S is equals to ut plus half at square. Why I mentioned this equation? Because we know the time, which is 0.9 seconds, and we know the initial vertical speed is zero. Horizontal is there, but the vertical, there is no component of the vertical motion. That's why initially it is zero. So this S will be h. Initial vertical component is zero, so zero multiplied by time, it will be zero, and then it will be half gt square. So the height is equals to 1 by 2 into 9.81 into 0.9 square. So if we need the height, then we will use this formula. So this is the expression to get the height, and this is the expression to get the range. As in the question they asked for range, that's why it was B. If they ask for height, then it will be C. In question 14, two projectile A and B are launched from a position O at the same time. At time t, both projectile have traveled horizontal distance OP. A projectile A is launched with the initial velocity of UA with an angle theta, and a projectile B is launched with the initial velocity of UB with an angle 45. We have to show that UA may be expressed in terms of UB because they both cover the same horizontal distance, so it means they have the same range. So we have UA. So this is equals to UA, and the launching angle of UA is theta. And there is UB, and its launching angle is 45. This is 45 and this is UB. Now, as I mentioned, at time t, both of these projectiles cover the same distance. Like in the beginning, they mentioned both projectiles have traveled the horizontal distance OP. So means at time t both have the same horizontal distance or both have the same range. So what will the expression for range of UA, like the horizontal distance for UA, it will have two components. The one of the component is with an angle, another component will be against the angle. Same thing, one of the component for UB with an angle, or another one is against the angle. So the horizontal component, which is next to it, that is UA cos theta. The component which is against, that is UA sin theta. Same way, the component which is with an angle, this will be UB cos 45 or cosine 45. And the component which is against the angle, that is equals to UB sine 45. Because they have the same range, so like we can say the range of UA is equals to range of UB. And we have to show that UA may be expressed in terms of UB. So if they have the same range, how I'll get the range of UA? Range is speed multiplied by time. Horizontal component of the speed multiplied by time t. And here also horizontal component of the speed multiplied by time t. As both have the same range, so I can simply compare them, like both cover the same distance. So I can say range of A is equals to range of B. Range of A is equals to UA cosine theta into T, and range of B is equals to UB cosine 45 into T. But they cover like they in the same time interval, so T will cancel with T. T is same for them. So when I simplify this, it will be equals to UA is equals to UB cosine 45 divided by cos theta. And cos 45 is equals to 0.707. So I can say UB into 0.707 is equals to cos theta. So the expression of UA in terms of UB, we have to show. So we have shown that because they have the same range, so speed into time for UA will be equals to speed into time for UB. So they will have the same speeds. They will have the same range, not the speed. Speeds will be different. Ranges are same. So that's why speed into time and speed into time will be equal for both of them. And T cancel with T. So UA cos or cosine theta is equals to UB cosine 45. Explain why for the path of two projectile as shown, UA is more than UB. So what is the reason why the UA, as you can see, is more than the second value UB? So as you can see that we have the formula UA cosine theta is equals to UB cosine 45. That is the expression, the previous expression. Remember that the value of the theta and the value of the cosine theta are inverse. If the value of the theta increase, the value of the cosine theta will decrease. So we want the product of UA cosine theta should be equal to UB cosine 45. So UA launching angle is more, means a greater launching angle is there. So when a projectile is launched with a greater angle, what will happen to its horizontal component? The horizontal component of the motion, like the cosine, because theta is inversely proportional to cos theta. If the angle theta increases, the value of cosine theta decreases. and the horizontal component of is given by UA cosine theta. So what happened? UA is having a larger angle, more than 45. So if it's having more than 45, the value of the cosine theta will decrease. If the value of the cosine theta will decrease, the value of UA should increase, or it should have a higher value. But for UB, what happened? It is cosine 45. So when it is cosine 45, as a smaller angle, as you can see, the UB is having a smaller angle. So if angle is small, the value of the cosine theta is large, because cos 0 is maximum. So if the angle is small, the value of the cosine theta is large. So here what happened? This cosine 45 or cos 45 will be small. Sorry, it will be large or a big value. As a result, the UB should be small, because we want their product to be constant. Like UB cosine 45 should be equal to UA cos theta. So if the value of the theta increase, the value of cosine theta will decrease. If value of cosine theta decreases, the UA should be higher. So when you mention the answer here, like compare the answer, the points which you will mention them in terms of angle. Is it clear, this part? Any doubt in this? The next one, on the axis below, sketch label graphs for the vertical component of the velocity for projectile A and projectile B between O and P. So we have to draw the vertical component of the velocities. Look, the vertical component of the velocity is UA sine theta, and this one is UB sine 45. And for sine theta, and you can clearly find that the vertical, because A is rising to greater height than B. So if A is rising to greater height than B, it means A is having a higher vertical component than B. Like this value UA sine theta will be more than UB sine 45, as A is rising to a greater vertical height. So whenever a projectile is launched, the vertical component initially, when it is going up, it will decrease, and then it is coming down, it increases. So for B, what happened? Till the halfway point, the vertical component will start to decrease, and then the vertical component of the velocity. Initially, it will be maximum, but start to decrease, and then when it is coming down again, it will increase, but in opposite direction. Where for A, what will happen? It is rising, its vertical component will decrease, but it will not be zero, because it is rising. So when we plot for A, and A is having a higher vertical component, so this will be for A. And B will have a lower vertical component. When it is going up, it is decreasing. Then when it is coming down, it will increase. So this one is for B. This one is for A. Why? Because A was rising. So its vertical component was decreasing, but even we cannot say, like, I don't say it can be zero, because it does not reach its maximum height. So even if I finish at this point, both lines should be parallel, because both have the same acceleration due to gravity. So here vertical component is decreasing, but it's not, still it does not reach a maximum height, so it is not zero. But for B, what happened? As it follow the trajectory, so the vertical component in its maximum in the beginning, then start to decrease, and at the maximum height it is zero. So this position, the vertical component is zero. And then it is coming down. So vertical component is increasing. Why the graph is a straight line? Because the vertical component is having a constant acceleration due to gravity. So whenever you have acceleration due to gravity, which is a constant, that's why the velocity time graph should be a straight line. It should not be curved. If it is curved, it means acceleration is different. We just need the vertical component. So vertical component, they have the same acceleration and deceleration. That's why it is a straight line.